Okay, so we are going to see the date range function in today's lecture. Particularly the date range function is part of pandas library. So obviously you have to import pandas by, we have imported it as PD, right? So PD dot date range, like that we are going to import that functionality from pandas. What this will do, it can do many functionalities that is associated with the date concept. Okay, so what are the parameters? If you look at the syntax, what are the parameters this date range function can have? The parameter like start, where you can specify the start of the date, or you can specify the end of the date range, that you're going to give a range between. So like, for example, starting from today, after 1,000 repetition, what will be the day, what will be the date, what will be the year, like that. You can do a lot of different functionalities that is associated with the date and the range of the date. So you can have multiple, these are the given parameters by multiple parameters are there. We'll see some important parameters. Starting of the date, you can give as a first parameter, and end will be the second parameter. That is optional, whether you can give start or end of the date. And then periods, that you can give the frequent, like how many 100 Sundays or 100 Mondays, like that. You can give the periods, or 110 days, any kind of period you can give here. Frequency and the time zone can be given, normalized name, you can give the column name, all those stuff. Okay, so this is the date range function, which is part of pandas library. So we are going to do some certain operations by using date range functions. Okay, so if you always you have to import the libraries once again. So I'm just going to create a new file. So you have to always import the all libraries once again when you start. So just import, go to that previous Jupyter notebook file and import all the libraries that we are going to use in today's practice. We may use NumPy pandas because those are mathematical operations we will do with any kind of data visualization. So just import those two. And today mostly we'll be focusing on Matplotlib, but import the CBAN as well. So just import all the library, and also we are going to import some of the NumPy operations like random, rand integer, rand whole number. So these are the functionality that we may use in today's practice. So import all of them. Okay, so we are going to focus in the date range function particularly today. So let's just create a data frame, just name it as DF or any name you can give. And we are going to use the date range function of pandas. We have imported the pandas as PD here. So just say PD dot date, PD dot, no, data frame. First, let's create a data frame of that. What the data frame will do? Data frame will create a table. Okay, so we are going to create a table that with the data of dates. Okay, and we are going to create some 1,000 random. What the random function will do? Random we have imported from NumPy. So what is the functionality of the random? It will create 1,000 floating point decimal, random decimal numbers. It will select randomly. So we are just selecting it. So that is going to be 1. And then in index, here we are going to create the date range function. So recall what the date range will do. It can just let us to play with date data. Okay. So let's say that we have, what's today date? 2022 04/19. Okay, so let's say this is going to be with 1,000. So 1,000 data, we're going to create 1,000, the period. So you can see the starting date. The first one is going to be the start date, and the second recall. What are the parameters it can have? It can have these parameters, right? So the start date, end date, all those. So we have just given the start date and the periods. Okay, so that's what we have given. And let's give some name for the column. Look at that. There is an option for, this is not for that. This is option for data frame functionality. Okay, so we can give columns. Let me pick it from here. Okay, so you can see the data frame will create a tabular column, and the tabular column is going to have 1,000 data, 1,000 rows, and the 1,000 rows is going to be the date data, which starts from today, and the periods is going to be the 1,000, and then column is going to be, the name of the column is going to be value. So we want to see what is there in the table. For that, we can simply use the pandas library head function. If you recall, we have used the head function. Head function, what it will do, it will just display a certain number of rows in the big table. For example, the table that we are right now creating has 1,000 rows. We just want to see the top 10 rows. For that, if you want to see 10, then it will give 10. You have to give 10. By default, it is 5. But if you want to pick 10 rows, then you have to give 10. So you can see from the 1,000 row table that we have created and saved it in the variable df, and by using the head function, we are just retrieving the top 10. And if you give 20, you can see it will just retrieve the top 20 rows in the table. So in this, you can see recall data frame what we have used and the head function. Okay, next we are going to see a concept called series. What is series? It's also a table kind of functional. It will create a table like data frame, like how data frame will create table, like that. Series is the function that will create table. But the thing is, like, it is one dimensional. It will have only one column. It like, by using data frame, you can create as many columns as you want. But in series, it is one dimensional. So holding only one data type with one column. Okay, it cannot. So you can see that it will not have any column name here. Here you can give column name, but if you're using series as a functionality to create table with one column, then you cannot give the column name. You can just give the index. Automatically, it will assign some index. Okay. So next, so far we have practiced data frame. Next, we are going to see series. What is series? Series is also a table thing. So let's create one series. Let's create a list. How can you create list? With square bracket. Let's create a simple list. Okay, we are going to create a series. And let's name it as series 1. And PD with the pandas. So both data frame and series, all of that belongs to pandas library. So from pandas library, I'm importing series. Let's see what is there in the series 1. So you can see what is there. It will automatically save it like a table, a column. It's simply column, but automatically it will create index. You cannot give any column name for the index. It is just index. Whatever you give, that will convert it into a table with some index. Okay, so not that much useful like data frame, but it will be helpful to handle one-dimensional data. So let's create one more series. Okay, let's create one more series. What is that syntax? PD dot, you have to give uppercase series, uppercase, yes, series. And so now we don't want that indexing with numericals. We want to give some alphabetical index. How can we do that? You can simply say index. You cannot give column name, but you can give index name. So you're going to give some alphabetical index for that. Okay, let's print it. Out of index. Okay, so that it seems like that we have 5 values, but we have given only 4 indexes. Okay, so let's play with the dictionary concept. We did it in our data even with the data frame. Let's do it in series. Let's create a dictionary, simple dictionary, and convert it into series. Okay, let's create a simple dictionary. How will you create dictionary? So it's like a recall. With the curly brace, you can create dictionary. Dictionary can have 2 key and the value. So let's create, how can you create series? PD dot series. And what you have to pass? You have to pass this variable that we have created. And let's try to print it and see what's that. It's supposed to give the table. Why it's not giving? Week, and we are passing it. It is supposed to give it in the dictionary form. Oh, sorry. We have saved it in the variable dictionary, right? So we have to print that dictionary. So this is where we have converted it into table, right? So instead of printing dictionary, I printed the variable, the dictionary variable. So if you print that dictionary where we have converted it into series, you can see table. So what you have learned in these practices, so like data frame, you can convert any data type into tabular column. The difference between the data frame and the series is it's multiple column you can handle. With the series, you can have only 1 column. So we have started with the date range function, right? So let's do something with the date range function. Okay, let's convert that. So we have done the data frame. We have converted the date range in data frame. Let's do the same thing with the series and see what we get. Okay, so I'm just going to copy this code where we have applied the data frame. And obviously, this is also a single column thing. So instead of data frame, we are just going to apply series. And in the series, all you have to remember is the column is not allowed in the series. Only the index value is allowed. So we are just deleting the column because that is the parameter of data frame function. Series does not support that. Since I already named that as DF, I have named this as DF1. So let's see the first, if I print everything, then it will be, there will be 1000 rows, which will fill the page. So I'm just going to print only top 10 rows. You can see the only difference, it is just taking that value as an index. Okay, just value as index. So because no column name is allowed. So the next thing that we are going to see is a function called cumulative function, which is part of NumPy library. So, which is part of NumPy library. Okay. So let me check it. Okay. So what it will do, it will create the cumulative sum of given data. For example, if you look at that, this 2 array, 1 plus 2, the first 0 plus 1, 1, and 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. So like that, it will create a cumulative summation as a sequence. Okay. So whatever you pass, if you pass this variable to the cumulative summation function, it will simply create the cumulative summation of values. Okay. So let's do that. Cumulative summation function. So first, let's create a simple array. So for that, we're going to use NumPy. And NumPy has a function, default function called array. We are going to create two-dimensional array here. The first row is going to have the value 1, 2, 3. And the second row is going to have a value 4, 5, 6. So we have a simple array here. Two-dimensional array. So create another dimension. So it has 2 rows and 3 columns. So let's call this cumulative summation function and pass this array to this and see what we get. You can see it will just create a single array with the cumulative summation values. Single array. Okay, so now what we are going to do, we are going to apply this df1 to the cumulative summation and see what's it. Doesn't need to be array. It can be any kind of data type that we can apply. So what we are going to do, we are going to apply the df where we have seen this. So here we are going to apply the cumulative summation on this. So you will see each of the index value will get the summation of the sequence value. Okay, so it has the value based on the indexing. We are going to do the cumulation summation. Okay, based on the indexing. So that means this. If you recall, this d value is this. So in this, we are going to do the cumulative summation. Okay, so df not the value. Okay, so we have saved it there, right, in the df. So we are just going to retrieve the first 10 values. So what do you see here? If you recall, the random value here, 106 and 0. So you can see the summation will be the first. And the second and third, the value will be, the summation will be here. You can check it here. You can see 1.15, which is nothing but 0.08 and 0.54. Okay, so like that, we are just where you want to do the cumulative summation, you can just give that particular column value and you can just simply apply the cumulative summation. Okay, so you're just exploring different functionality. Now, next we are going to move some plotting functionality on that. Okay, so we have already seen the plotting in our previous exercise. So let's continue how to do the plotting on the data whatever we have created so far. So how to use the plotting. Let's create a variable. It's simple list of numbers first. I can just create any kind of list. How can we convert it into series? Let's create a variable and just call the series function. Pass this. I'm just giving a lot of exercise so that you will be familiar with all this functionality. So how can you do apply the simple plotting? So we are going to apply the plotting on the series of this data. So that is saved in the variable S1. So S1 dot plot. If you recall, we have seen the plotting in our last class. We started the plotting. So plot is the function that belongs to all the libraries has the same built-in function name, plot. Simple plotting can be done. So if you recall, so you can see the indexing value based on the indexing. Just by default, it takes 0, 1, 2, 3, 4, and the x coordinate will be some scaling 0, 1, 2, 3 x coordinate value, and the y coordinate value is going to be this. Okay, so it starts from 10 and ends in 80. Okay, so it just plot the data according to a sample normalized x coordinate position. So let's apply this plotting on this complicated data that we have created. What complication? So we have created some 1,000 data, right? So let's that will be interesting, more interesting and more real time when we have more data. So let's apply this plotting on our DF and DF1. We have the DF with the data frame and DF1 with the series. So let's apply it on DF. You can see the date range function that we have created. If you plot it, this is what you will get. Okay, so with this is 1,000 data. You can see from the date for 1,000 days from 2023, 24, 25. So I gave the a particular date as a starting date and 1,000 occurrences with some indexing value. Okay, so it just took that date as the x coordinate and just plot the values. Okay, so this is how we can do. We can customize this figure size as well. There is a parameter called figure size that will help us to customize the figure size. Maybe I'll show you the syntax. So the figure size is the parameter that we can modify the size of this window by using this figure size parameter. Okay, so first one we have to pass the width and the second one is the height. We can pass it to change the figure size. Maybe we'll apply this on this 1,000 data plot to see how we can change the figure size. So maybe df dot plot figure size equal to the window size is going to be 10 and 20. You can see this is how it looks. If you want to change it to 20 and 20, it will be like a square. And if it looks very big, let's change to true, 5 and 5. Okay, so you can customize the figure size accordingly. Okay, by using figure size parameter, you can do that. You can play around with that. So next, let's move on to, so these are some basic plot function. We started plot functionality in last class itself. Now we are moving on to matplotlib. Okay, matplotlib, if you recall, it's a very popular two-dimensional library. Two-dimensional library has a lot of functionality that we can use to analyze the data. So we are going to start the MATLAB library. Let's do some basic operations using that. Okay, so let's create some array. So MATLAB library particularly will be useful to work with array, mostly in image processing. Image will be considered as an array. Rows and columns of pixel values. So mostly image processing will use MATLAB, matplotlib or MATLAB. What that's kind of similar functionality in matplotlib. The MATLAB and NumPy and pandas. So all those things can be combined together. So it's kind of pretty much advanced. Okay, so let's create two arrays and let's call the matplotlib library to plot it. So if you recall, we have already imported the matplotlib library as PLT. So what is the name that we have to call? PLT dot, and any function that we want to utilize from matplotlib, we can call that. Okay, let's first create a simple data. So let's create an x coordinate. Let's create an x coordinate. So with the NumPy, already we have seen it has a function array that will create array of values with starting value 1 to 8. If we give like this, it will create a simple array. And let's create a y coordinate with the NumPy and again with the array function. Okay. Now we're going to call the PLT where we have imported the MATLAB as PLT. So as I told you, most of the libraries has the same built-in function name for simple plotting. So the MATLAB library also has the same function name plot to call the simple plotting. And we are going to plot this X and Y value that we have created, the two array value that we have created. So, but in MATLAB, to show the plot here, simply by creating the plot, you can see, but in MATLAB, to show the plot, you have to call the function called show. So that will just show you the, so to display the plot, you have to call the show function. Simply that also will create, but as an object. Simply the plot also will show, but as an object, it will show it along with the object. So let's try this plot on this DF that we have created, this 1000 data. Let's try that on the MATLAB lib. How can we call that? PLT plot function. What parameter we have to pass? DF. That's where we have saved our data. You can see it will just give you the object. If you don't want to see the object, then simply say plt.show so that it will not create you the object. Simply it will just show you the values. Okay. So now we are exploring MATLAB library, how to show basic plotting using MATLAB library. Let's do some bot shot. Let's do some bot shot. How can we do that? df dot plot. If you recall, that's a parameter called kind. It will take some time. Okay, it will take some time. This is the bot shot. Let's create a, okay. So if you want to create a horizontal bot shot, bot, this also will do the job for you. You can do this. You can either pass the parameter bar or you can simply call the function bar. That also will do the same job for you. In case if you want the bot chart to be horizontal rather than vertical, then you can say df plot dot bar horizontal h bar h. You can see for the 1000 data, we have created the horizontal bot chart. So some basic data that we just created our own data by using data frame and series and did some basic plotting function. Now we are going to import the real world data set and do the plotting. So it is just like a introduction, but really the real power of data visualization, all the functionality you can realize when you work with the real data set. Okay, so there are a lot of options are there, a lot of data sets are there. Okay, so for example, we are going to start with a data set called Irish data set. So we have imported all these libraries, the Seaborn, MATLAB, they themselves have a lot of data sets available. But we are just going to use some of the data set from Seaborn library. To use it, I want you to go to this Seaborn library. maybe just type GitHub Seaborn data, iris data. So let's just type Seaborn iris GitHub. Just type it. The first link that you will see is the Seaborn library. So we are just going to import this iris data set from Seaborn library. So this data set has 151 rows. So what is this data is about? This data is about some classification of the flower species based on the parameters called sepal length and width and petal length and width. Based on this 4 value, they have classified that iris flower into 4 different categories. So this data set is all about that. So we are going to import that. Okay, we are going to import that from the Seaborn library. So how to import that? How can we do that? So if we have imported the Seaborn library as SNS, right? So we can call that SNS dot load data set is the function name. So to import any data set that is there in the Seaborn library. So the Seaborn is not only has the functionality, but it also has a lot of the data sets that we can play around with the functionalities. So it has a function called load data set. By using that function, we are going to call iris data set. For that, just pass the parameter iris. And that also has, Seaborn also has the head function like pandas. So we are just going to see the first 10 rows. So iris is not defined. Oh, I didn't define I didn't create the iris object. First, I have to create the object iris. And we are just loading the iris data set just by importing that SNS libraries, Seaborn. Now you can simply call the function and load the data set. I just want to see what are the other data sets. You can see like iris data sets. In GitHub, you can find lot of data sets. Maybe I will ask you to pick one like this, and that may be your homework. Okay, I may ask you to pick some of the data set from here and play around with that. Okay, so we just pick this iris data set for our lab, but you may do something like this in your homework. Okay, so just now you have to go to the SNS, import the SNS, and then load the data set iris. Okay, so now what we are going to do, we are going to plot. We are going to plot that data set. We are going to analyze the data set. Now we are analyzing it numerically, but we want to analyze it by using the graph. How can we do that? What are the things that we can utilize to look at the data set in graph, as a graph, so that we can have more in-depth knowledge. So let's create a variable called just give any name. And we have saved this in object called iris dot plot. So you can see even in Seaborn, in MATLAB it is plot, it is pandas, it is plot. In Seaborn also the function name is plot. And then also you can use the parameter, figure size parameter, that is also same in most of the library. We are just setting some window size 1010. And we can give the title of the graph by using the title parameter. Okay, we can just give the title for the graph. It is iris dataset, exploring iris dataset. You can give any name, any title for your graph. Exploring iris dataset. Okay, so we are setting ax dot set underscore x label. It's a function. It's a function. You have to use it. It's the function that is going to say x coordinate. And similarly, by calling that object, we're going to call set y label. Now we are looking at the, instead of looking at that as a table like this, we don't get anything. It's just number. But when you see this like this, it beautifully plot the data. So you see, you can see it try to interpret the graph. So it has 0 to 151. You can see how many rows are there. 151 rows are there. Look at the graph. In x coordinate, it has 0 to 151. So these are nothing but the index value. X coordinate is nothing but index value. What are the y coordinates? Y coordinate is nothing but this value. The length, width, whatever we have, that value. Okay. So for example, you take this first data. What is the first data's 5.1, sepal length 3.5, 1.4, 0.2. Look at that interpretation. So by default, it is just taking each column and it gives some color to that column and just it's plotting it. So let's take this the orange color plot. What is the orange color plot? It is sepal width. So what is sepal width? It is 3.5. So if you take the first row, it is 3.5. That's why it starts from 3.5. This is the data for the first row. Okay. Similarly, if you select the last row, it is 151. Okay. The sepal width is 3.9. Sepal width is 3.9. Sorry, 3.0. Let's try to interpret it in the graph. Do you see here? The last value is 3.0. So by using the simple plotting function, you can just convert the data set, any big data set, into a simple graph so that you can do better analyzing by using plotting. So let's see what are the other things that we can do. So what we are going to do in this label, we are just going to see if we don't want any particular column, how can we drop that column? For example, here, we are not seeing anything, we are not getting anything from this new in this text data, like based on this numeric, they have classified it, right? So we don't want this classification. We are just going to plot the number. We cannot plot this text data. So we are going to, we want to drop the species. How can we do that? The last column is not needed in the data set. So we can simply remove that from the data set. To remove that, we have to use a function called drop. So drop function. So let's create a data frame, df iris dot drop. So from the iris is nothing but that. What is iris? It's the object we have created and we have saved that. We are loading it the data and saving it in iris. So we're calling that iris and then we are calling the drop function. What we want to drop? We want to drop that species column. What is the name? So this species is the name. So we want to drop the species column. So you can type it or just copy and paste. We want to drop that last column. You can even drop it by the indexing or column name, whatever. So we want to drop it and we want to look at the date after that. df dot head and just look the first 10 rows. You can see we have removed that species column now. So previously it had that species column. Now we don't have that species column. You can do it for any value. For example, if you don't want to have the petal width, the last one, we don't want to have the petal width, you can remove it. df1 equal to iris dot drop function, and we want to drop the petal width. If you're not giving, if you're not using the head function, we're simply um, uh, displaying the sorry, df1. I have to show this df1. So you can see now it had removed the petal with keeping the species in df1. Okay, by default you can see it just shows some here, it just shows first row, but if you simply display the object itself, it will simply show the first 5 rows and the last 5 rows and showing how many rows are out of that. Okay, so if you're doing the head function, it will just pick the top 10 rows or top 5 rows, whatever you have given inside this parameter. That many number of rows will get retrieved and displayed. But if you simply call this function, then it will just pick the first 5 rows and the last 5 rows and display it. Okay, so we have seen how we can use the drop function to remove certain column. Let's do this plotting now without this petal with data set. Let's see how it looks. Okay, so maybe df1 plot. Let's create a bigger size. Do you see? Since we have removed the petal with column, so that we're just plotting the 3 columns. So the fourth feature is not getting displayed here. So if you want to select a particular row, you can see there are 150 different flowers. But if you want to just select one particular row, you can do that too. For that, we have to use the ILOC function. For example, let's say DF. DF has all 4 features, and ILOC, index location. So if you want to pick the first index, then you have to give the index number as 0. So the index location of a particular row that can fetch all the four given column value of particular row, and it can fetch it. ILOC, you can give any indexing. For example, the last indexing value is 151, right? So you have to give 150 for the last index. DF ILOC square bracket 150, that will pick up the it is out of index. Okay, let me say 149. Okay, so that is the last indexing value. So leaving the title. So we have plotted the whole data set, right? Even we can plot a single row. How can we do that? Even we can plot a single row. For example, let's say this first location, ILOC 0, we can do the plotting on that. Plot, and you can type any kind. See? Automatically, it will pick the column name and just display it. So you can do any kind of visualization using these libraries. Okay. So in this previously, we have plotted the whole data set, but here we have just plotted a single row. Try this bar hedge. I don't know. What is the horizontal bar score? Did we try histogram? I remember like we have discussed about histogram in the last class. Yeah, we did, right? So histogram is nothing but, let me take that. So we discussed about histogram, which is nothing but like frequency, like occurrence, based on the occurrences. For example, if you are plotting a histogram for image, how many 0 pixels are there? How many 255 pixels are there? Like that, the frequency of occurrences can be plotted by using histogram. Okay. So let's do some histogram kind of operations now. Okay, so maybe we can take that iris data set and let's plot some histogram on that. So plot hist function. You can see the sepal width, sepal length, and petal width, petal length, how the values are getting accumulated in this graph. You can see this here. I can do this like this, or I can simply use the kind parameter. Okay, either way. You can just call it as a function or you can call it like a parameter. If you want to just do for only one column, we have seen how to do it for only one row here, right? We just pick one row and just plot it. If you want to pick only one column and plot it, you can do that too. How can we do that? Just pick the column name. For example, we want to plot the sepal length only. We don't want to worry about the other columns. We just want to pick the sepal length. Maybe. This typo error. Okay, so you can simply plot a particular row, a particular column, or the whole data set, or any kind of data. You can pick anything. In this histogram, we have left that one data set, one column, right? Let's try to plot that and see how it looks for the histogram. DF1 does not have the petal width. Let's plot it. Okay. So we can just do any kind of visualizations. So actually now let's do some more parameters. Let's explore some more parameters. So like a stock bar is kind of a plot where each bar is visually divided into sub-bar representing multiple column data at once. You can see here the stacked bar is a plotting type. You can see how they are sharing the data. So you can see how the orange and green overlap. The same thing, you can just do it with bins and stack. Stack will create a will combine different columns together in the same row. Okay, so it's kind of plotting. So let's do how to see that stock with the bin option. Bin will create like the category like a bar kind of categorized plotting can be done by using bin value. So let's do that with added stack value and the bin value. Iris plot. Let's say the histogram. Type is histogram. And stack is going to be true, getting stacked one after another. So if it is true, then the values will get piled up in each x coordinate position. So the bin, we are going to have 100 bins. 100 bins. So with the 100 bins, it is very thinner. But if you reduce the size of the bin, then it will be wider. You can see, if you reduce the size of the bin, it will be wider. You can try with that horizontal borrowing. You can convert that into horizontal borrowing. Iris, plot, kind, list, stack, true, bins, let's say 50, orientation. Here previously we used the bar h or b or h, bar h, right? Here we have to use the parameter called orientation and then just use horizontal. There are slight variations. Most of the basic functionality will be same in all libraries. But when you go for advanced options, there may be light variations. Then you have to give horizontal.
Why is true in quotations?
Okay. Stacked true. That is why it's getting stacked. See, you can see.
That's not the way it's right on the other. We didn't put.
By default, it is true. Yeah, it doesn't matter because by default it is true. That is the thing. Even if it is wrong, it is working because it doesn't care about that syntax error. By default, it is true. Okay. Now we are going to see what are the other mathematical functions that we can apply and try to plot it. There is a function, difference function, DIFF, difference function that we can apply on any of these columns and see whether it calculates the difference between remember we use cumulative sum, right? Like that we can see cumulative differences between the two rows. For that we can use iris. Let's pick any column. Sepal. Let's pick the sepal width and difference. You can see it picks each row and just subtract that second value from the first value and calculate the differences between the first value to the last value. Okay. So if you want to plot this to see how it looks like, to get some idea about this difference, we can do that. We can plot it. I didn't save the variable, but if I have saved the variable, we can apply that. Since I didn't save the variable, plot time. Let's pick histogram because just one column, we can pick anything. And stock by default, it is true. And the bin, number of bins, let's keep it as 50. You can see this is the difference plotting. Okay, it's 12:15.